Okay, 1.2, this is all about exponents. Number 1, express the number in the form of a over b, where a and b are integers. So you just have to work these out. So on number 1, you have negative 2/3 to the 4th power. That means you have 4 of them. And any time you raise a negative to an even power, it becomes positive. So really what we have here is 2 to the 4th and 3 to the 4th. 2 to the 4th is 16, and 3 to the 4th is 81. So 16 over 81, all right? And we just keep going. Number 2, negative 3 to the 3rd. Now a negative raised to an odd is going to be negative because you have 3 negatives multiplied together. Negative times a negative is a positive, and then times another negative is a negative. All right, so 3 cubed, 3 times 3 is 9, times 3 is 27. So this will be a negative 27 as your answer. And if you're writing it as a fraction, then it's negative 27 over 1. Number 3, 2 to the negative 3 and 3 to the negative 2. Anytime you have a negative exponent, you have to move its base to the opposite side. So that would be to the opposite top or bottom. So it's in the numerator, it's going to be in the denominator. That becomes 2 to the positive 3. It doesn't change the positive or negative on the base. So the 2 doesn't become negative. And if it was negative, it wouldn't become positive. So, and then the 3, that's got to move to the numerator. And it becomes positive 2 for the exponent. So now you have 3 squared is 9, 2 cubed is 8. All right, number 4, you have 2 to the 0 plus 0 squared, and 2 plus 0. So do each of these individually. 2 to the 0, anything to the 0 power is 1. 0 squared is 0, and 2 plus 0 is 2. So this answer is 1/2. All right, and then we go to number 5. Negative 2 to the 4th plus 3 to the negative 1. Now, the negative 2 to the 4th, the negative is not on the 2. That's really negative 1 times 2 to the 4th plus 3 to the negative 1. So negative 1 times 2 to the 4th. 2 to the 4th is 16 times the negative 1 is negative 16. And 3 to the negative 1, that's in the numerator, so we need to move it to the denominator. And 3 to the 1st is 3, 1/3. So now you have negative 16 plus 1/3. So now we need a common denominator, so multiply the left by 3 over 3, and that gives us negative 48 plus 1 on the top, all over 3, or negative 47/3. Number 6, negative 3/2 to the 4th power minus 2 to the negative 4. So again, the negative in this one, number 6, is inside the parentheses. On number 5, it was not inside the parentheses. So this is still, on number 6, negative 1 times 3/2, but when you do that, it's negative. So we raise that negative to the 4th power, it's going to make it positive. So 3 to the 4th is going to be 81. 3 times 3 is 9, times 3 is 27, times the 4th 3 is going to be 81, and 2 to the 4th is 16. And then this is a negative exponent, so it goes to the denominator, so 1 over 2 to the positive 4, or 1 over 16. So you have 81 minus 1 is 80 all over 16. And that answer is now, you have to reduce it by 8, and you get, it's 5. If you just keep reducing it, you're going to get 5. 80 divided by 16 is 5. So the answer should be 5 over 1. Number 7, 9 to the 5/2. So now we get into radicals. And the bottom number is always what the root is. So this is going to be the square root of 9 to the 5th. So you can do 9 to the 5th, or you can do the square root of 9 and raise that answer to the 5th. Okay? So the square root of 9 is 3, and 3 to the 5th, 3 times 3 times 3 times 3 times 3. So 9 times 3 is 27, times 3 is 81. 81 times 3, 3 times 80 is 240, and 3 times 1 is 3, so the answer is 243. Or use your calculator to figure it out. And again, as a fraction, it's 343 over 1. Number 8 is 16 to the negative 3/4. And again, you have a negative exponent, so we're going to move the... Okay, so we're going to move this to the bottom, the denominator, 1 over 16 to the positive 3/4. And again, the denominator is of the fractional exponent is the root. And you can either cube 16 or cube the answer, and it helps to know what the 4th root of 16 is. 4th root of 16 is 2. So now you have 1 over 2 cubed, and that is 1 over 8. That's the answer. All right, so let's get rid of all this stuff and do number 9 and 10. All right, number 9 is negative 0.008 to the 2/3. So we're going to take the cubed root of negative 0.008. And you can take the cubed root, 5th root, 7th root, the odd root of a negative value. So the cubed root of negative 0.008 is negative 0.2. If you use your calculator, you'll see that. And then if we square that, we're going to get 0.04. Okay, and then number 10, we have 0.008 to the negative 2/3. All right, so again, the base has to be moved to the denominator, so it's 1 over 0.008 to the positive 2/3. All right, so that's 1 over 0.04. Well, you can't leave it like this. Can't have decimals in your fractions, so it's 1 over 4/100ths. So we take the top times the reciprocal of the bottom. 100 over 4 is 25. 1 times 25 is 25. And you have to leave it as a fraction, so 25 over 1. Now let's go on to number 11. Okay, 11. 1/2 x to the 4th times 16 x to the 5th. All right, it's all multiplication, so technically we don't need any of the parentheses. So you have 1/2 x to the 4th times 16 times x to the 5th. We can rearrange any multiplication, so it's 1/2 times 16 times x to the 4th times x to the 5th. Half of 16 is 8, and when you multiply like bases, you add the exponents. All right, number 12. Negative 3x to the negative 2 times 4 times x to the 4th. Again, you don't need the parentheses because the exponents are not on the outside. So negative 3 times 4 is negative 12. And now you have x to the negative 2 times x to the 4th. Like bases, you add the exponents. So negative 12, negative 2 plus 4 is positive 2. And that's your answer. All right, let's get rid of that. And we'll start with number 13. All right, number 13 is 2x cubed and 3x squared. And that's the top. Let's go ahead and just do the top first. So the top, again, there's no exponents on the outside here, so we don't need those parentheses. 2 times 3 is 6, and multiplying x times x, you add the exponents. 3 and 2 is 5. And then on the bottom, you raise an exponent to another exponent, you multiply them. So that's x to the 6th. And now you have fractions with like bases. So you have 5 on the top and 6 on the bottom. If you just subtract those, you got to put it in the top. 5 minus 6 is negative 1. Or you can say 5 of these cancel with 5 of those, leaving 1 on the bottom, which is what this would be if you moved this to the bottom to have a positive exponent. So 6 over x is your answer. 14. 2x squared cubed times y squared. Now those parentheses can't go away until you take care of the 3. On the bottom we have 4x to the 4th y squared. Okay, So let's go ahead and take care of this exponent. So everything has an exponent, even the 2. So we need to distribute the outside exponent. So that's going to be 2 cubed and x to the 6th times y squared. And on the bottom we have what we started with. 2 cubed is 8. So 8 over 4 is 2 in the numerator. And x to the 6th over x to the 4th. 4 of these cancel with 4 of those, leaving 2. So that's x squared. And y squared over y squared is 1. So the answer should just be 2x squared. All right, let's get rid of this and start on 15 and 16. All right. 15. 1/6 a to the 5th and a negative 3a squared. Again, no exponents on the outside, so we don't need those parentheses. Let's look at the last one, 4a to the 7th. Yep, don't need the parentheses. So we can rearrange all the letters and the numbers. So 1/6 times negative 3 times 4 times a to the 5th times a squared times a to the 7th. All right. Add all your exponents. 7 and 7 is 14. That's a to the 14th. And now we do this. So we get negative 3 times 4 is negative 12 over 6. So the answer should be negative 2 a to the 14th. Great. Now let's do number 16. Negative 4 b cubed times 1/6 b squared times negative 9 b to the 4th. And of course, no exponents on the outside, so we don't need those. We can rearrange everything. Negative 4 times 1/6 times negative 9 times b cubed times b squared times b to the 4th. So that is b. 3 plus 2 is 5 plus 4 is 9. And over here we have negative 4 times 1 times negative 9 is positive 36, all over 6. So the answer is 6b to the 9th. All right, let's go on to number 17. Let's get rid of this stuff. All right, 17. 6x cubed squared and 2x squared cubed times 3x squared to the 0 power. Okay, so let's do the numerator first. So that's going to be 6 squared, which is 36, because you have to distribute to everything inside the parentheses. And the 6 has a exponent, remember, of a 1. So 6 squared is 36, and 3 times 2 is 6. Now let's do the denominator. Again, distribute the 3 to every exponent inside. 2 cubed is 8, and 2 times 3 is 6 again. And now we look at this. Anything to the 0 power is 1, so that's gone. X to the 6th over x to the 6th is 1. So we have 36 over 8, which we need to reduce by 4. 36 divided by 4 is 9, and 8 divided by 4 is 2. So 9 halves is the correct answer. Now number 18, you have 3y cubed and 2y squared to the square all over y to the 4th to the 3rd times 5y to the 3rd to the 0 power. So that's going to be 1, because anything to the 0 power is 1. 3y to the 3rd can't do anything. We need to do something with this 2, so we distribute it to each exponent inside. So this becomes 2 to the 2nd. So we have 3y cubed times 2 squared is 4, and y squared squared is y to the 4th. All over y to the 12th. 3 times 4 is 12. Raising an exponent to an exponent, multiply. 3 times 4 is 12. And now you have like bases in your numerator, so you add exponents. That's y to the 7th over y to the 12th. So 7 of these will cancel with 7 of those on the bottom, leaving 5 on the bottom. So your answer should be 12 over y to the 5th. You could have written it as 12 times y to the 7 minus 12, and you would have gotten 12 times y to the negative 5, which, again, that would have to move to the bottom to make it a positive. All right, moving on. Number 19. So 3u to the 7th, v to the 3rd. There's nothing to do with that. The next one is 4u to the 4th, v to the negative 5. All right, nothing to do with this, so we don't need the parentheses. We can rearrange everything. So 3 times 4 is 12. Then we have u to the 7th times u to the 4th times v cubed times v to the negative 5. All right, so that's 12 u to the 11th. You add when you multiply like bases, times v. 3 plus negative 5 is negative 2. So this would be done except for the negative exponent. That needs to go to the denominator. So your answer should be 12u to the 11th all over v to the positive 2. And that's your answer. Excellent. Number 20. Number 20 is x squared y z cubed. Nothing to do with that. Negative 2x squared and x cubed y to the negative 2. So no exponents on the parentheses. You don't need the parentheses. It's all multiplication, so let's rearrange everything. We have a negative 2, and now our x's. X squared times an x cubed. Make sure we get all those. Times a y to the negative 2 times z cubed times z squared, and that's all of those. So now what do we have? Negative 2 and x. Don't forget there's a 1 on everything for an exponent. There's a 1 there and there's a 1 on the y. So add those together. 2 plus 1 plus 3 is 6. 1 plus negative 2 is negative 1. And for z, 3 plus 2 is 5. So you'd be done except for that negative. It needs to go to the bottom. So negative 2, x to the 6th, z to the 5th, all over y to the 1st. And that would be your correct answer. All right, next slide. Number 21, we're just going to keep going with these because they're complex, and you need to be good at these. So 21, 8x to the 4th, y to the negative 3, and you have 1/2 x to the negative 5, y squared. So I didn't put parentheses on here because there's nothing on the outside of the parentheses that has to be taken care of. So if there's nothing there, they're just ones on the outside. So you don't need the parentheses as long as it's all multiplication inside. So now rearrange everything. 8 times 1/2 times x to the 4th times x to the negative 5 times y to the negative 3 times y squared. Half of 8 is 4. 4 plus negative 5 is negative 1, and negative 3 plus 2 is negative 1. So this needs to be changed, and this needs to be changed. So our answer should be 4 over xy, both of those to the first power. Okay, number 22. So I'm just looking at the problem instead of writing everything down here. There's nothing on the outside, but you have fractions inside the parentheses. So we probably should put everything together, or you could write everything together on the top and the bottom. So 4a squared b, 5a squared b. It's all multiplication, so you can do this. If you have plus and minus operations, you can't do this. A cubed b squared 2b to the 4th. So what do? You could treat these separately. Like this is the first part. You could do them separately, so we can do that. I'm going to do it all together as one. So 4 times 5 is 20. And a squared times a squared is a to the 4th. And b to the 1st times b to the 1st is b squared. On the bottom, you have a 2. A cubed is by itself. And b squared times b to the 4th is b to the 6th. Remember, multiplying like bases, you add exponents. Now, 20 over 2 is 10. A to the 4th over a cubed. 3 of these will cancel with 3 of those, leaving 1 on the top. That's a to the first. 2 of these will cancel with 2 of those on the bottom, leaving b to the fourth on the bottom. That is the easiest way to do those. All right. And let's do number 23. 23. You have this negative 2 on the outside, so you need to distribute that through. So let's just write it out this time. So you need to take this negative 2 and multiply every exponent by it. So multiply the negative 3, multiply the 4, and multiply the 1/3 to the first power. So this is going to be 1/3 to the negative 2, x to the negative 8, and y to the positive 6. Now this goes in the denominator, that goes in the denominator. So we have y to the 6th on top, 1/3 squared on the bottom, and x to the 8th on the bottom. So y to the 6th over 1/9 x to the 8th, except you can't leave a fraction inside of a fraction. Okay? So you take the top times the reciprocal of the bottom, and that's what you get. You get 9 y to the 6th over x to the 8th. Now, something you probably should do instead of this may have been confusing. I would have taken the negative exponent and just flipped everything that negative exponent is hooked to and moved it as a base. So you have this negative 2 out here. Let's move this whole thing to the base. So I would have started it like this. 1 over 1/3 x to the 4th, y to the negative 3, raised to the positive 2. You still get the 1/9 in the denominator. So that should tell you something, that you just take that fraction and move it to the top as its reciprocal, and you'll get the right answer. All right, 24. Number 24. So we have an exponent outside of this parentheses. Let's go ahead and take care of that. Each one of these have its exponents, so distribute it through. Negative 2 to the 5th, x to the 5th, y to the 10th. All right? And then the next one is y to the 7th, x to the 7th over 8y cubed. Okay, so what do we have on top? You have negative 2 to the 5th. 2 to the 5th is 32, so that's negative 32. X to the 5th, and you bring that other x to the 7th in there with it together, and y to the 10th. And then on the bottom you have 8y cubed. So 32 over 8, that's negative 4. X to the 12th. And then these 3 on the bottom cancel with 3 of those, leaving y to the 7th on the top. All right, that's your answer. All right, let's get rid of these. And number 25. So 3y cubed raised to the 4th. Let's go ahead and do that first. Again, everything has an exponent. That's 3 to the 4th, y to the 12th. 3 to the 4th is 81. Now let's do the second part. You have 4y squared raised to the negative 3. So again, distribute the negative 3 to each exponent. 4 to the negative 3, y to the negative 6. So 4 to the negative 3. 4 cubed is 4 times 4 is 16 times 4 is 64. So this is 1 over 64 because you got to make that a positive exponent. So this is 1 over 64. And this y to the negative 6, that goes on the bottom to make it a positive 6. Now what do we really have? 81 over 64, y to the 12th over y to the 6th. 6 of these will cancel with 6 of those on the top, leaving 6 left. 81 and 64, check to see if those reduce. And as you go through and check for yourself, you'll see that that doesn't reduce. The answer is 81 over 64, y to the 6th is in the numerator. 81, y to the 6th, all over 64. And that is your answer. All right, next problem, number 26. negative 3a squared b to the negative 5 raised to the third power. All right, again, distribute to every exponent. So negative 3. Now, it's a negative on the inside, and when you cube a negative, you're going to have a negative answer at the end. So don't forget that. Make sure you kind of watch for that stuff. A to the 6, b to the negative 15. When you distribute an exponent, it's multiplication. So now you have negative 3 cubed. That's negative 27. A to the 6th, and then this needs to be replaced so it's a positive 15. Move to the denominator. And that's your answer for 26. All right, number 27 is negative 2 r to the 4th s to the negative 3 to the negative second power. Again, distribute to every exponent. But that's a negative on the inside, okay? So this will be negative 2 to the negative second power. Now, I told you on one of the previous problems, if your exponent's negative, you could take the whole thing and put it in your denominator and change that negative 2 to a positive 2. And when you do that, which is really what you should do, if you have a negative exponent on the top or on the outside of a parentheses, flip it all upside down and make it a positive exponent. And so now we have 1 over negative 2 squared r to the 8th s to the negative 6. So this positive exponent is going to make that negative go away. This negative exponent moves this up on top, s to the positive 6th. On the bottom we have a positive 4 r to the 8th. Okay, number 28 is 2x squared times y to the negative 5, 6x to the negative 3 times y, and 1/3 x to the negative 1 y. Okay, so again, there are no exponents on the outside of the parentheses. Everything's multiplication. We don't need the parentheses. So 2 times 6 times 1/3 times x squared times x to the negative 3 times x to the negative 1. And then times y to the negative 5 times y to the first times y to the first. And in my picture, I cannot tell if there was something here. So hopefully this is right. Let me check that. Okay, it was y to the third on that y. So we need to put a y cubed here. Alright, so putting everything together, 2 times 6 is 12, 1/3 of 12 is 4, and then multiplying like bases, add your exponents. 2 plus negative 3 is negative 1, negative 1 plus negative 1 is negative 2. And then your y's, negative 5 plus 1 is negative 4, negative 4 plus 3 is negative 1. So each of these need to be moved to their opposite positions. So it's 4 over x squared times y. Alright, going on to number 29. Alright, 29. 5x squared y to the negative 3 times 4x to the negative 5 y to the 4th. And again, nothing on the outside, so it's 5 times 4, x squared, x to the negative 5, y to the negative 3, y to the 4th. 5 times 4 is 20, and times x to the 2 plus negative 5 is negative 3, negative 3 plus 4 is 1. So there's your negative exponent. It needs to be moved, so 20 times y to the first over x to the positive 3 is your answer. And number 30. Negative 2r squared s. And raise that whole thing to the 5th. So let's go ahead and just simplify this before we do the next one. Again, you have exponents. The negative 2 has a 1 on it. the s has a 1 for an exponent, so distribute the 5 through. But before you do, remember that the negative's on the inside of the parentheses. So raise that to the odd power that remains negative. So you have a negative 2 raised to the 5th power, r to the 10th, and s to the 5th. So now look at the other part of number 30. 3r to the negative 1, s cubed raised to the 2nd power. So again, 2 to the, times 3, 2 times negative 1, and 2 times the 1 exponent gives us 3 squared r to the negative 2, s to the 6th power. Multiplying all of these together, negative 2 to the 5th is negative 32, 3 squared is 9, r to the 10th times r to the negative 2, so r to the 10th times r to the negative 2 times s to the 5th times s to the 6th. 32 times 9 is the same thing as 30 times 9 plus 2 times 9. So 30 times 9 is 270, plus 18 is 288. So negative 288, r to the 12th, s to the 11th power. That's a mistake. This is negative 2 on the r, so 10 plus negative 2 is 8. So this should be r to the 8th. Next problem. 31. Now we start getting a little more complex. So we need to distribute this 2 to everything. So I'm going to rewrite all of this. 3 squared, x to the 10th, y to the 8th, and z squared. All over. Again, distribute the 2 through everything. 0 times 2 is 0. Y to the negative 6, and z squared. Alright, now simplify. 3 squared is 9. And put your like bases together. X to the 0 is just 1. So x to the 10th is still on top. Negative 6 and y to the 8th. So put your base in the numerator. Take the top numerator minus the bottom numerator. And z squared over z squared is 1. So all we have to do at this point is figure that out. 9x to the 10th, change, is y to the 14th power. Number 32. So again, let's do one of these at a time. So 4a squared b, all of that raised to the 4th. And the other one is negative a cubed 2b raised to the 2nd power. Alright, so distribute the 4 to each exponent. There's a 1 on the b, and there's a 1 on the 4. So 4 to the 4th, a to the 8th, and b to the 4th. Now this is going to be squared, so this negative is on the inside. Negative raised to an even exponent makes it positive. So this is just going to be, you distribute the 2 through, be a positive a to the 6th power 2 squared b squared. Alright, so 2 squared is 4. This is all over 1. So we can rewrite it so you understand it here. 4 to the 4th, a to the 8th, b to the 4th, a to the 6th, all over 2 squared b squared. 4 to the 4th, 4 times 4 is 16, times 4 is 64, times 4 is 236. Oops. Put your a bases together. That's a to the 14th, b to the 4th. On the bottom, that's 4b squared. That should be 256. Okay, and then 256 divided by 4 is back down to 64. So 256 over 4 is 64. A to the 14th, and then your like bases there. Those 2 will cancel with 2 of these, leaving b squared on top. And that should be your answer. Alright, let's do 33. negative 5a to the 3 halves, 2a to the 1 half. Alright, so we could put these in radical form, but let's go ahead, since they're like bases, we can just add the exponents. There's no exponents on the outside besides 1, so you don't need the parentheses. So negative 5 times 2, you can rearrange everything at this point, times a to the 3 halves, times a to the 1 half. So negative 10, and add your exponents, 3 halves and 1 half, is 4 halves or 2. That's your answer. Next question. 34. Negative 6x to the 7/5 times 2x to the 8/5. Again, no exponents that need to be distributed, so you do not need these parentheses. And it's all multiplication. So negative 6 times 2 times x to the 7/5 times x to the 8/5. Negative 12 x to the 15/5. So negative 12x cubed. Number 35. So I'm just going to look at it now. No exponents on the outside, so we can rearrange everything. 3 times 8 times x to the 5/6 times x to the 2/3. So 24. Now you need to have a common denominator to add these together. So multiply by 2. So that'll be 5 plus 4 is 9 over 6. 9/6 is 3 halves, so 24x to the 3 halves. That's your final answer. And 36. Now you can't just write these down. You have an exponent on the outside of the parentheses of 1/3, and 2 are to the 1 half. So we need to distribute the 1/3 for each of the exponents. Each of these have an exponent of 1, so it's 8 to the 1/3, r to the 1/3. No exponent over here to distribute, so you don't need the parentheses anymore. So, 8 to the 1/3, you can't put it with a 2 because they're not the same base. You can make it 8 a 2 by saying 2 cubed. We're not going to go there yet because you should know that this is the cubed root of 8 to the first power. The cubed root of 8 is 2. So now you can put 2 times 2 together, that gives you 4. And so now you have r to the 1/3 plus 1 half. So 1/3 plus 1 half. Common denominator is 6, so multiply by 2, multiply by 3. 2 plus 3 is going to be 5, all over 6. And that's your final answer. Alright, 37. Okay, 27, a to the 6th. To the negative 2/3. Alright, distribute the negative 2/3 in. Alright, before we do that, I told you if you have a negative exponent on a parentheses, you need to move that whole thing to its opposite position to make it a positive 2/3. So this is going to be 1 over 27, a to the 6, raised to the positive 2/3. Now distribute the 2/3 through. So 27 to the 2/3. A to the 6 times 2/3 would be 12/3, or 4. So what is 27 to the 2/3? So the denominator is always your root, and the 2 can go on the 27 or can go after you do the cube root. The cube root of 27 is 3. So this answer should be 9. So our answer should be 1 over 9a to the 4th. 38. Z to the fourth to the negative 3/2. So, again, you have a negative exponent. You can distribute it first and then move them if you want, but I'd rather have negative exponents to start with, or positive exponents. So, again, 1 over 25z to the fourth raised to the negative 3/2, positive 3/2 now, because we moved it. So, distribute 3/2 through. 1 over 25 to the 3/2. 4 times 3/2 is 12/2, or 6. So again, let's take a look at that. The denominator is your root. So this is the square root of 25. And the 3 can go on the 25 or it can go after. So it would be better to do the square root first. So 5 cubed is 125. So our answer is 1 over 125 z to the 6th. Okay, so number 39. 8x to the negative 2/3. And that is times x to the 1/6, not raised to the x to the 1/6. So again, there isn't any other exponents to distribute, so this is just all multiplication. 8x to the negative 2/3, x to the 1/6. So all you have to do at this point is put your like bases together by taking negative 2/3 plus 1/6. Get a common denominator by multiplying by 2. So that'd be negative 4 plus 1 is going to be negative 3 all over 6, or negative 1/2. So if your exponent is negative, we need to move it to the denominator. So this is 8 over x to the positive 1/2. And that should be your answer. Okay, number 40. 3x to the 1/2 times negative 2x to the 5/2. Again, there's no exponents to distribute. So we'll take 3 times negative 2 times x to the 1/2 times x to the 5/2. Add like, multiply like bases, you add the exponents. That's x to the 6/2 or x cubed. 3 times negative 2 is negative 6. And that's your answer. Next slide. Now we're getting more complex. 41. Negative 8x to the 3rd. Y to the negative 6. All raised to the 2/3. I apologize, this is sloppy. I am in a car. Now, inside the parentheses, it's negative. It's raised to an even exponent. The 3, the denominator here, represents a root. So you could take the cube root of a negative and you'd get a negative. But then you still have to square it. You're taking it to an even root. So this negative is now not even necessary. Okay, so let's distribute the 2/3 through. 8 to the 2/3. X to the 3 times 2/3 is 6/3. And y to the negative 6 times 2/3 is negative 12/3. Simplifying, first, the denominator of your fraction is your root. And we know the cube root of 8, so we'll do the cube root before we square it. Cube root of 8 is 2. 2 squared is 4. 6 over 3 is 2. And negative 12/3 is negative 4. So to make that positive, we're going to move it to the opposite position. Numerator, y to the 4th. So 4x squared, y to the 4th. Alright, number 42. Negative y to the 3 halves over y to the negative 1/3. Okay, so inside the parentheses, it's negative, and we're raising it to an odd exponent. So that means it's going to remain negative in the end. The negative on this exponent in the denominator has no bearing on positive or negative of the whole value of the problem. This just means we need to move this up top. So we're going to have y to the 3 halves, and then we move the bottom part up, we get y to the positive 1/3. But remember, you have a 3 still on the outside. You could have distributed it first. It doesn't matter when you do it. So let's distribute it now. You have negative y to the 9 halves times y to the 3/3. Okay, which is 1. And if you have like bases, you add the exponents. So 9 halves plus 1 is the same thing as 9 halves plus 2 over 2, or 11 halves. So our answer should be negative y to the 11 halves. All right, number 43. X to the 6th over 16y to the negative 4 raised to the negative 1/2. Again, if your exponent's negative, let's go ahead and move everything to the bottom. Now, here's another little tip. If it's a negative exponent on a fraction, all you have to do is just flip the fraction upside down. So let me give you a quick example again to remind you. Let's say we have 2/3 raised to the negative 4. So if we move this to our denominator, that's 1 over 2/3 to the positive 4. And of course that's going to give us 1 over 2 to the 4th is 16, and 3 to the 4th is 81. And you have a fraction inside a fraction. What do? You're going to take the top times what? The reciprocal of the bottom, which is what 2 to the 4th and 3 to the 4th is, but flipped upside down. So instead of going through all of that, all you have to do is flip the fraction, flip this fraction over and keep the 1/2 on the outside, but make it positive. So here's what it looks like. 16y to the negative 4, x to the 6th, raised to now the positive 1/2. So that's what a negative exponent does on the whole fraction. It just flips it over. Or you could distribute the negative 1/2 to every exponent and work it out by itself. You'll still get the same thing. But if you can remember this, it saves you the trouble. Now distribute the positive 1/2. 16 to the 1/2, y to the negative, 4 halves. Give me a second here. Negative 4 halves. And on the bottom you have x to the 6 halves. 16 to the 1/2. The 1/2 is a square root. The 2 is your root and the 1 is your exponent. So you have the square root of 16 to the 1st, which is just 4. Alright, so that's 4. Times y to the negative 2 and x cubed. Last thing, you got to make that positive. So it's 4 over x cubed y squared. Alright, number 44. C to the negative 4 over 81d to the 8th. All of that raised to the positive 3/4. So let's distribute the 3/4 to every exponent, including the 1 on the 81. So c to the negative 4 times 3/4 all over 81 to the 3/4, and d to the 8 times 3/4. So this is going to be a negative 12 over or c to the negative 3. Now, let's do the d. 8 times 3 is 24. So 24 over 4 is 6. So this is going to be d to the 6th power. 81 to the 3/4. Remember, the denominator is your root, so the 4th root of 81. You can go ahead and cube the 81, or you can cube the answer of the 4th root of 81. 4th root of 81 is 3 raised to the 3rd power, which is 27. Last thing to do is make your exponents positive. 1 over 27 c cubed d to the 6th. Alright, 45. X to the 6th y cubed to the negative 1/3, and x to the 4th y squared to the negative 1/2. Okay. The negative exponent in the numerator is not on a fraction. It's only on the top part of the fraction. So we're not going to just flip it and keep the 1/3 and the 1/2 in the same place like we did on that last problem. But we do need to move this to the bottom to make that a positive 1/3. And we need to move this whole thing to the top to make that a positive 1/2. So because they both have negative exponents, we're going to flip each base to the opposite position. Here's what it looks like. X to the 4th, y squared to the 1/2, positive 1/2, all over x to the 6th, y cubed, raised to the positive 1/3. Now distribute. And again, you can always distribute first. There's multiple ways to go about doing this. So when you distribute, multiply. So 4 times 1/2 is 2, 2 times 1/2 is 1. On the bottom, 6 times 1/3 is 2, and 3 times 1/3 is 1. And you notice those reduce to 1. 1, 1. And 46. A to the 4/3 times a to the negative 3/2 times a to the 1/6. Multiplying all like bases, so that means we're adding the exponents. 4/3 plus the negative 3/2 plus a 1/6. So 6 is your common denominator, so we're going to multiply by 2 in the first fraction, by 3 in the second fraction, and the 1/6 doesn't need to change. So we have 8 plus a negative 9 plus a 1 all over 6. 8 plus negative 9 is negative 1. Negative 1 plus 1 is 0. 0 over 6 is 0. So that's your answer. Okay, so now we're going to look at fractions for exponents, and you see the radicals here. And radicals, again, are just fractions as exponents. So just real quickly, if you have the square root of 16, what that means is it's 16 to the 1st over the 2nd power, meaning 16 to the 1/2. So what we're going to do is we're going to take these radicals and turn them into fractions. Alright, let's get rid of all that. Alright, number 47. So you have the 4th root of x to the 4th plus y. Alright, so the group, the parentheses, is the x to the 4th plus y. That's under the radical, so it's grouped together. Now, there's a 1 on the outside for an exponent and the root of 4, so that's 1 over 4. Okay, so at this point, you're done because you cannot distribute that exponent into this parentheses because you have a plus or minus sign in there. It's not the same thing. On all the other problems that we've done, there weren't plus and minus signs. And that's the only time you can distribute that exponent. So this is the answer. X to the 4th plus y as a group to the 1/4 power. Alright. Number 48. So all you're doing is rewriting this. So the group is x cubed plus y squared raised to the 1/3 power. Because there's a 1 as an exponent and the 3 is the root. Alright, 49. The group is a plus b. And now here, the 2 is on the inside of the radical. It doesn't matter if it's on the inside or the outside. And it's on the group. So that goes there, and the root of 3 still goes in the denominator. And number 50, the group is a plus, and now the square root of b, again, is b to the 1/2. Alright, so that's the group under the radical. There's a 1 for an exponent, and since you don't see a number for the root, that means it's a 2, so it's to the 1/2. Again, you can't distribute these exponents because of the plus or minus sign that's inside. Alright, 51, the group is x squared plus y squared. And again, what is the exponent on the group? A 1, and the root is a 2. And 52. The group is r cubed minus s cubed. And the exponent on the outside is a 1, and the root is a 3. So there you've rewritten all of these as rational exponents. So you have to make sure you remember when you can distribute an exponent and when you cannot. Alright, next page. So sorry about the rain in the car. I'll stop and do the rest of this later. Okay, so now we're going to go backwards. Instead of taking a radical and making it into an exponent, we'll take the exponent and make it into a radical. So the important part here is that we understand what the group is. On number 53, 3/2 is on the x, not on the 4. So 53a, it would be 4 times, and you put a radical in, the x goes inside, and remember the denominator of your fraction goes on the outside as the root. The top number goes on the inside. It can go out here, but we'll go ahead and put it on the inside for now. As opposed to b, 53b, the 3/2 is on the whole group. So whatever the group is, that goes underneath the radical. And again, the denominator is a 2, and the numerator is a 3. So here's the trick here. If you put it on the x, that's wrong. You would have to do it like this. So there's a couple different ways you could write this. You could say the square root of 4 cubed, which is 64, and then x cubed. You could write it as the square root of 4x, and then put the 3 on the outside of the radical. That would be the exact same thing. So all 3 of these would be correct. Alright, 54. So 54a, you have 4 plus, and then the x has the fractional exponent. Alright, so there you have the radical, the fractions on the x, so the bottom number is a 2, so it's the square root. We don't need to write a 2 if it's a square root. And then the 3 goes on the outside or inside. So if it's just one thing, you can go ahead and put it like that. So 4 plus the square root of x cubed. Alright, so b, the group is 4 plus x. So 4 plus x is the group. We put it under the radical, 4 plus x. And then the denominator is a 2, so that's your root, square root. And the top number is a 3. So again, you either put it out here, or you have to write it like this, with parentheses raised to the 3rd power. And again, you cannot distribute that 3 through. As opposed to there, you could distribute the 3 through here, and that's how we got 64 and x cubed. But this has a plus sign on it, so you cannot do that. So either one of these 2 answers is correct, and move on to the next one. So we are going with 55a. The exponent's only on the y, so it's 8 minus, put a radical, the y goes there, the bottom number is a 3, so it's a cubed root, And the 1 is an exponent. You don't need to write the 1. If you want to, you can put it in there. And 55b, you have the whole group has the fractional exponent, so that's underneath the radical, 8 minus y. And again, it's a cubed root, so the 3 goes on the outside. Alright, so let's get rid of some of these and do 56. 56. Now the 1/3 is on the y, so the 64 is on the outside of the radical, and the y goes on the inside. The 3 is the denominator, so it is your root. And the 1 goes on the inside on the y. You don't have to write a 1 as an exponent. Alright, so b, the 1/3 is on the whole group of 64y. So now you have 64y on the inside. It is the cubed root because the 3 is on the denominator. And the 1 would go anywhere you want it, but you don't have to write the 1 as an exponent. The problem with this one is this is not finished, because you can, if there's no plus and minus sign, you can take and split apart radicals and say that this is the cubed root of 64 times the cubed root of y. Well, the cubed root of 64 is 4. 4 times 4 is 16 times 4 is 64. And then you're left with the cubed root of y. So technically that is your answer. If you can simplify, you should always simplify. Alright, next page. Okay, simplify the expression and rationalize the denominator when appropriate. Again, I apologize for the sound quality here. On these set of problems, you actually have some numbers. You get to simplify them. Go ahead and solve them or reduce them as far as you can. So let's look at 57. 57 is the square root of 81. Hopefully everybody knows that that's 9. That's the answer. 58 is the cubed root of negative 216. So remember, if your root is odd, you can take the cubed root of a negative, the 5th root of a negative, the 7th root of a negative. You cannot take an even root of a negative. So this answer is going to be a negative something. So you can use your calculator if you'd like, but you need to learn what these are. So 216. Okay, so you can take the cubed root of a negative 216, that would be negative 6. 59. So it might help you just to go and make a whole list of numbers that are squares, cubes, and even to the 4th and 5th powers. So 59 is the cubed root of negative 64. It is the 5th root of negative 64. And again, you can take an odd root of a negative. So at this point, 2 to the 5th power is 32. 3 to the 5th power is going to be 300 and something. So it has to be in between 2 and 3. But we're not going to use a calculator, we're just simplifying. So we can take... Okay, so we got to break this apart. The 5th root of, let's say, negative 2 and positive 32. Doesn't really matter. Negative 2 times 32 is negative 64. So we can split these up. The 5th root of negative 2 and the 5th root of 32. So the 5th root of 32 is 2. So your answer should be 2, 5th root of negative 2. But we're going to put the negative on the outside. So negative 2, 5th root of 2. And there you'll get your answer. Alright, let's clean this up. And do the next one. That would be the 4th root, number 60. 4th root of 512. So let's do this one a little differently. Let's go ahead and break this down to practice figuring out what you can take out of a radical. So let's just break this down into the 4th root of 2 and the 4th root of 256. So 2 times 56, not 65. So that would be 512 if you multiplied 2 times 256. And And then you keep going, just keep breaking it down. And you could do 2. Now we can figure out the 4 through 256. If you don't know it, then you got to keep breaking it down. You want to keep going until you can break something out. So 2 times 128 will give you 256. Again, keep breaking these down. You just have to keep working until you understand exactly what you can break it down into. So 2 times 64. Now you should know what that is, but we'll keep going to show you something. So the 4th root of 2 times 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 the 4th root of 32. Okay, so whatever your root is, in this case it's a 4, you're looking for 4 of them. Just like the square root of 16, that breaks down into the square root of 4 times the square root of 4. Alright, you know the square root of 16 is 4. Well, the root is a 2, so you need 2 of the same radicals of the same root to get there. On the 4th root, here, you need 4 of the same radicals. So, 2 of the same radicals on the left here will give you the number without the radical. On the right, 4 of the same radical will give you that number without the radical. And then you still have the 4th root of 32. And that can be broken down as well. So if we just kind of keep going here, the 4th root of 2 and the 4th root of 16. Again, if you don't know, you just keep going. 4th root of 2, the 4th root of 2, 2 times 8. Keep going, 4th root of 2, 4th root of 2. Break down the 8, the 4th root of 2, and the 4th root of 4. Alright, and then that goes again. Let's make a little space right here. Bring this over to this direction here. Let's do the next level by breaking down the 4. So you have the 4th root of 2, 4th root of 2, the 4th root of 2. You break down the 4th root of 4 into 2 other ones. That would be the 4th root of 2 and the 4th root of 2. So again, we need 4 of the same ones. So there's 5 there. We'll take those 4. That means it's a 2 without the radical. So what do we have? We have that 2, we have this 2, and the 4th root of 2. So put it all together. 2 times 2 times the 4th root of 2. So you have 4 and the 4th root of 2. That would be your final answer. So let's go back up to this position. If you have your numbers out from your notes, if you lay out the numbers of the squares and the cubes and the 4th roots, you'll know that this is 4. The 4th root of 256 is 4. And then you have that left over. That's where your answer comes from. Alright, let's clean this up and do number 61. Over the 2 cubed root of 2, so the 2 to the 1/3. Okay, so here's the thing where you can't have a radical in your denominator. It's called rationalizing your denominator. So let's do an old school type of problem. Let's say we have 1 over the square root of 3. You can't have a radical there, so what you used to do is multiply by the square root of 3 over the square root of 3. That gives you the square root of 3. And again, this is a square root, so if you have 2 of them multiplied together, it's that number without the radical. Okay? So that's why we multiply by the same square root to remove it. But that only works with a square root. So let's go up here. The whole point is, let's bring that back for a second. Alright, so look at the denominators here. If we put these as fractional exponents, this would be 3 to the 1/2 power times the other one, 3 to the 1/2 power. What happens when you multiply like bases? You keep the base and add the exponents. 1/2 plus 1/2 is 1. That's why this works. So if we apply this concept to the top problem, we got to multiply by a radical that gives us a 1 for an exponent. So keep the bases the same, and what would the exponent have to be if you add 1/3 to it to get to 1? It would have to be 2/3. So we're going to multiply the top and the bottom by the same thing. So now you have 2 to the 2/3 power over 1. Over 2, excuse me, 2 to the first power. So your answer, if you put it back in radical form, the top one, the bottom number is your root, and you have your base, and then it's to the second power. And on the bottom you have a 2. Alright, so 2 squared is 4, so this is the cubed root of 4 all over 2. That would be your final answer. Alright, number 62. We have the square root of 1 over 5. So let's break it apart. You have the square root of 1 over the square root of 5. And something times itself as 1, that would be 1. And now we have, like we had on the last problem, this would be 1 over the square root of 5. And since it's a square root, we just need 2 of them. We're just rationalizing them like normal. So that's square root of 5, and that's 5. That's your final answer. So let's see here, 63. Now we're going to get a more complex. Square root of 9x to the negative 4 and y to the 6th power. Alright, so since it's all multiplication, we can break all these apart. You cannot do this if you have plus and minus signs. So we have the square root of 9, you have the square root of x to the negative 4, and the square root of y to the 6th. You know the square root of 9 is 3. And maybe you don't know what the square root of x to the negative 4 is. So let's make it a fractional exponent. There's your base. The root is on the bottom, so this is a square root, so the 2 goes on the bottom, and the exponent goes in the top. So that's going to be x to the negative 2. Same thing with the y. The root is a 2, so that's on your denominator, and the exponent is a 6. So that answer is y to the 3rd. And you can't leave it like that. No negative exponents. So we move it down. So this is 3y cubed over x squared. Alright, number 64. Square root of 16a cubed b to the negative 2. Alright, so that's b to the 8th, or excuse me, a to the 8th power. So again, it's all multiplication. We can break it apart. The square root of 16, the square root of a to the 8th, and the square root of b to the negative 2. And if you can do this without breaking it down like that, that's okay. The square root of 16 is 4, and again, this will be a to the exponent over the root, and b to the exponent over the root. So we simplify that. 4 times a to the 4th, b to the negative 1. That's got a switch, so it's 4 a to the 4th all over b to the positive 1. That's your answer. 65. 65 is the cubed root of 8a to the 6th b to the negative 3. Again, let's split them apart. Cubed root of 8, cubed root of a to the 6th, and the cubed root of b to the negative 3. Cubed root of 8 is 2, a to the exponent over the root, b to the exponent over the root. 2, a squared, b to the negative 1. So it's 2a squared over b to the positive 1. Next, 66. 66. of the fourth root of 81, r to the fifth, s to the eighth. Alright, so let's do this without splitting it apart. We can go ahead and split the 81 out if we want, and try to figure that out if you'd like, if you don't know what the answer is. But let's go ahead and do r to the exponent over the root and s to the exponent over the root. So what do we have? The fourth root of 81, if you break it down, is going to be 3. 3 times 3 times 3 times 3 is 81. And this is r to the 5/4 and s squared. Alright, so the problem now... Okay, so the problem that we have to look out for is when your exponents are improper fractions. So let's take a look at r to the 5/4. Make it a mixed number. That would be 1 and 1/4. That means you can take 1r out of your radical. So this would be 3r s squared, and then you would have the fourth root of r to the first. That's where the r to the 1/4 comes from. Alright, let's move on to number 67. 67 is the square root of 3x over 2y cubed. So with all multiplication and division, there's no plus or minus signs in here, we can break these apart. Square root of 3x over the square root of 2y cubed. And if we keep going and keep breaking them apart because we're not sure exactly what to do, you can break apart multiplication. The only thing that can be done, anything that can be simplified, would be that right there. And you also cannot have a square root or any radical in your denominator. So let's attack the square root of y cubed. Again, that's going to be y to the 3/2, and as a mixed number, that's y to the 1 and 1/2. So you have 1y that needs to be on the outside of the radical, and then you're left with y to the 1/2 inside the radical. Okay, so the top is the square root of 3x, the bottom is the square 1y being brought out, and then under the radical is 2y. But we need to rationalize the denominator, so we're going to multiply both sides by the square root of 2y. And we get the square root of 6xy on the top. On the bottom we have y, and these two radicals cancel each other out, leaving just a 2y. So on top is the square root of 6xy, on the bottom is 2y squared. And that is the final answer. 68. And the square root of 1 on the top, and the square root of 3x cubed y on the bottom. The square root of 1 is 1, and now we have the square root of 3x cubed y on the bottom. So again, we need, before we rationalize, let's go ahead and break apart that radical. 1 over the square root of 3, the square root of x cubed, and the square root of y. The square root of 3, that's x to the 3/2. As a mixed number, that's x to the 1 and 1/2, which means you can take 1x outside of the radicals, and there'll be an x to the 1/2 left inside the radical. So here's what it looks like. 1x is on the outside, and you're left with the square root of 3xy. Alright, now when we rationalize, we multiply by 3xy over the square root of 3xy. And that radical goes away. And we have the square root of 3xy all over x times 3xy, which is the square root of 3xy all over 3x squared y. That's the final answer. Alright, number 69. The cubed root of 2x to the fourth y to the fourth over 9x. So let's put everything in radical form here, or rational exponents here. But we can also simplify first. I'm always in favor of simplifying everything you can before you do the bigger stuff. Not always, but almost always. So we can combine this x to the fourth and x to the first on the bottom. So let's rewrite this. Cubed root of 2 x to the fourth over x to the first, one of these x's on the bottom, which would be the whole thing, simplifies with 1 on the top, leaving x cubed. And you have y to the fourth there. And on the bottom we have the cubed root of 9. Okay, so before we rationalize again, let's go ahead and take care of what we have on the top. You have the cubed root of 2, can't do anything with that. You have the cubed root of x cubed, which should be x, and the cubed root of y to the fourth. So let's take a look at this. That's y to the exponent over the root, and again we simplify that as y to the 1 and 1/3. So we can take one y out, and we still have a cubed root of y left inside. So on the top we have the cubed root of 2, an x on the outside, and a y on the outside, and a y on the inside. That would be the y to the 1/3. And now we have the cubed root of 9 on the bottom. So let's rewrite that as 9 to the 1/3. So to rationalize something other than a square root, you have to multiply by something where your exponents add up to 1. So that'd be 2/3. Alright. So on the bottom we have a 9. 9 to the first power. On the top, let's go ahead and change the 9 to the 2/3 back into the cubed root of 9 squared, or 81. The cubed root of 81. So if we put those together with the top, you have an x on the outside, a y on the outside, and the cubed root of 2y times 81. So x, y, cubed root of 162y, all over 9. And that's your final answer. Okay, now let's get to number 70. Is the cubed root of 3x squared y to the fifth, all over 4x. So let's simplify on the inside first. And the x's will go together. So one of these x's will cancel with 1 on the top, leaving just 1 on the top. So 3x and y to the fifth all over the cubed root of 4 on the bottom. So before we rationalize the denominator, let's take a look at the top. Can't do anything with the cubed root of 3. And we make the x a fractional exponent. The exponent's 1, the root is 3. Can't do anything with that. And then the y is 5/3, and that's the problem. So on the top, we can go ahead and put that x back with 3. The cubed root of 3x. But the y is now y to the 1 and 2/3. So the 1 means we can have 1 on the outside. So it's y cubed root of 3x. And the 3 on the 2/3 is your root. And the top number is your exponent. All over 4 to the 1/3. Now we can rationalize the denominator by multiplying by 4 to the 2/3. And I'll write it like this in the top. On the bottom we have 4, and on the top we have y cubed root of 4 squared is 16. You're going to take that times the 3, that's 48. And you have x, y squared. You'd almost be done, but you should figure out what the cubed root of 48 is. So it's the cubed root of 8 and the cubed root of 6. And know what the cubed root of 8 is. That's 2. So the 2 is on the outside, so our new answer is 2y cubed. And then, I'm sorry, not 2y cubed, 2y. And we have the cubed root of 6xy squared all over 4. And you're not done because you can reduce the 2 and the 4. So that's y, cubed root of 6xy squared all over 2. That would be your final answer. Alright, moving on.